All right, well, hopefully you enjoyed her explanation of how long-term potentiation allows for neurons to start solidifying their communication directly between the two of them to share specific information about a memory. The next question, though, about physical storage of memories is where are the memories? Where are the memories stored? And it turns out that it depends on what kind of memory we're talking about. So we're going to I didn't do the numbering on this on this diagram. I'm going to start up here at the top because that makes the most sense to me. So up here in the top part of our brain, ahead of what is known as the motor strip, which is this little what we call sulcus right here, which is in front of this big deep. I'm sorry, this is a gyrus here. This is the sulcus, this big deep divide between two parts of the brain. So this is what we call the central sulcus. And then this is the motor strip gyrus, which is where all your control over your motor movements occurs. Right in front of that is where memory for motor behaviors occurs. So a lot of procedural memories can be housed here. Ones that you can do on purpose or that you're still in the process of learning tend to be housed up here in the motor cortex region of the frontal cortex. Once you've really overlearned it and it's become automatic, well, then those things tend to hop down here into the cerebellum. Being able to walk, being able to chew, these kinds of motor things that you do with absolutely, no conscious awareness most of the time, that's housed in the cerebellum. Farther forward in the frontal lobe, there, we believe, are a lot of different semantic and what we call episodic memories. Your knowledge for things that happen and you know when they happened. That would be your episodic memory store. And so the frontal lobe, we think, houses a lot of the details about understanding and integrating those kinds of memories. The prefrontal cortex, which is the very farthest part forward of your frontal cortex, that's where a lot of your working memory that is held longer, like a month or 2 months or something like that, is probably housed up here in the prefrontal cortex. The temporal lobe, which is over here, it's in the lavender area, that stores memories having to do with sound, because that's where your auditory cortex is. So your sound recollection will occur here in the temporal lobe. And then there are structures in the temporal lobe, the hippocampus and the amygdala, that are important for, in the hippocampus, temporarily storing information before it gets consolidated up into your long-term memory store. And your amygdala is where emotional content will be added into memories. This isn't labeled on this picture, but back here in the very back, the green area is your occipital lobe, and that's where vision is processed. So a lot of the visual aspects of a memory will be stored back here in the hind part of your memories. The emotion that came out of the amygdala and it is tied to memories oftentimes will be stored up here in the parietal lobe on the top of your head. The key thing, though, is that memories can technically be stored pretty much all over your cortex. There's not a specific area that is your memory area. And these memories are stored in these neural networks that we talked about, with interconnections among the different aspects of whatever the memory is. And so there's a lot of your brain will light up, we call it, when you look at a functional MRI and you see that there's like these, what we call hot areas of your brain. They're like more white or yellow in color rather than blue or green. Those areas are really super active. And they may not be the specific location where that specific detail is housed. It might be the neural network that's getting activated, and a lot of, additional details are being activated in different areas of the brain are being pulled in that really don't have, direct specific storage of the memory in question. So the point is that we're not exactly sure where everything's housed. Our best evidence for where information is housed comes from people who have had damage to different areas of their brain and have lost retrieval of information. And so then we guess that information must have been housed in the part of the brain that got damaged. But it's possible that the part of the area that got damaged is actually the way station between two areas that are actually housing the memory. And with that part gone, those areas can't communicate anymore, and therefore the memory can't be retrieved. Maybe the memory is still in there, but it can't be consolidated together into one coherent memory because the area that does that is gone. So it's we're in the very baby stages of understanding exactly where memories are housed. That's the basic premise that I'd like to leave you with. All right. So let's talk about how we get information back out. So it's really awesome if you can put information into your memory store, but it's useless if you can't get it back out and provide evidence that you know that, right? Like, so what if it's in there if you can't find it? Just like half the things I end up buying for a second time. That's great that I own it, but I can't find it. So I'm going to have to buy another one of those. Very annoying, but true, right? You guys can all probably relate to that. So when we go to retrieve something from our memory, it's really important that we have adequate cues for retrieving that information. A cue is a prompt that helps us to retrieve the encoded memory. The cue might be a question on an exam. And you guys have had these experiences where you feel like the cues are inadequate. Like you did know that information, but that cue that was provided on the exam was not sufficient to get you to retrieve the information, right? If you had just asked more clearly, I would have been able to tell you that I knew that, right? Sometimes you've had experiences where maybe you were watching a video on YouTube or something and it made you think of something because the context of the video or whatever triggered, it served as a cue for you to retrieve some memory, something that you already know, something you can relate to, something like that, right? So sometimes the cues are inadvertent. Sometimes they're just, sort of out in the environment and they make you think of something. Now, the associative strength theory says that strongly associated cues are cues that have been frequently paired with the material. And those kinds of cues really enhance memory, right? So if we have cues that have been repeatedly tied in lots of different contexts with this same material, it makes it much more likely that cue is going to be sufficient for us to retrieve the material. Related cues oftentimes will prompt retrieval. It doesn't have to always be these super strongly related associated cues. It could also be things that are sort of tangentially related, can serve as prompts for retrieval. So with the associative strength theory, the idea is that the more strongly associated, the more directly related, the more the cue will actually serve as a prompt. As you get into more weakly associated or indirectly related or not related at all cues, well, that's not going to serve very well for retrieving information. We can use free association as a good example of the connections that must exist among the things that you have stored in your memory or between prompts out in the world and your ability to retrieve. So I'm going to give you some cues and you're going to just think of the first word that comes to mind. And obviously you don't have to say it out loud because I can't hear you, but here we go. First word that comes to mind in response to boy: large, night, salt, table, over, more. So look at what you generated, think about what you generated, and we might get some evidence for what your neural net looks like. So for a lot of people, the first word that comes to mind is like oppositional things. So they might have said boy, girl, large, small, night, day, salt, pepper, over, under, more or less. Notice I skipped table because what's the opposite of a table? A lot of times you'll find that some aspects of our neural net are organized in sort of utilitarian ways. So what goes with table is the thing that you use with the table, which is chair, right? So you might have thought table, chair. with these really, they've generated really long lists of prompts and then asked people, write down the first thing that came to mind, and have found that a lot of things are in fact this oppositional thing. But then also there's sort of like these categorical or utilitarian kinds of associations that we have also. Since there is no such thing as the opposite of a table, it probably makes a lot of sense that it has, a more utilitarian association. Categorical associations are common also, where you have, if I said hammer, you might say nail. Or if I said wrench, you might have said pliers, right? Like things that are sort of alike and they belong in the same category. Hammer and nail are kind of utilitarian. Wrench and pliers are probably more categorical, right? So the first thing that comes to mind might help us to get some understanding of what's like how your mind is organized, right? What things are associated with what in your mind. The fact that that you have these connections provides evidence that you probably do have a neural net organization in your brain. Now, the encoding specificity principle says that memory is best when the retrieval condition matches the encoding condition. So memory is best when the retrieval condition matches the encoding condition. Now, back in 1965, Godden and Baddeley tested this with some scuba divers. Now, going into it, their assumption was that having to either learn the list or retrieve the list underwater would be stressful, and that stress would interfere with memory. Like that was their hypothesis going in. What they found is not quite as much evidence that being underwater is stressful, but much more that memory is best when the retrieval condition matches the encoding condition. So if we look over here at the graphic, we see the participants either learned the list while underwater and then retrieved the list while on land, or they learned the list while they were on land and retrieved the list while they were underwater, or they learned the list underwater and got tested underwater, or they learned the list on land and they got tested on land. So on the left-hand side of the diagram, we see those situations where the context differed between, encoding and retrieval. So you got the learned underwater, retrieved on land. On the far left, you've got the learned on land, retrieved underwater as the next one in, those two green bars. You see that the percent of words recalled is a lot lower for those mixed contexts than it is for the same context. So you got the learned underwater, retrieved underwater condition in the red bar, and they remembered about 30% of the words. They learned on land, got tested on land, almost 40% recall. Both of those bars are substantially higher than the bars where they had to learn, encode the material in one context and retrieve it in another. This really surprised Godden and Baddeley because, like I said, they thought being underwater would be stressful. And so anytime you had to do any component of either encoding or retrieval underwater, that you would, they expected the first three bars to all be low and the land to be the high bar. But what they found is, nope, context is key. And so what we realize now is that when you're encoding information, you don't just encode the information, you encode the context in which you are experiencing the information. And so one of the things that's super important as a student is to try and make your learning context as similar as you possibly can to your testing context. So the best thing you can do is when we're back to face-to-face, when you're in a face-to-face class, is to actually attend class. Because being in that same room for learning, hearing the lecture and participating in the class, being in that same room for learning, as you will be for taking the test, is going to cause you to perform better on the test than if you, just stayed home, did your own reading, and then came to the class to take the test, right? Because now you're going to have a mismatch between encoding and retrieval. Now, the best, most ideal thing you could do is sit in that same room and do all your reading, but I don't know if that would work. So, if you can, why not? If you're on campus and the room's empty, sit in that room to do your studying. But if that doesn't work out, it's okay to have a little bit of mismatch, but you want to have as much match as you can. So attend class. Now online, it's kind of an advantage taking an online class because you're on your computer or tablet or whatever you're using to take the class to do your reading. You're on it to do your class. You can actually start getting a little mixing and matching though, where if you're taking a bunch of classes online, it all starts to kind of blend together and you lose the distinctiveness of being in a different classroom for psychology than you are for math or whatever other classes you're taking, right? And then it all kind of just becomes one big blob of learning rather than, a specific place for learning each subject. So one of the things that you can do in an online scenario is designate one part of your living situation as your place where you study for psychology, another part of your living situation being your math study place, or time of day can serve as context. So you maybe study psychology in the morning and you study math in the afternoon, or however your schedule works. So making difference between different topics and then consistency within topic will boost your memory over the long run. It'll boost it, like not enormously, but you see like a 10% boost, even if you had to be tested and learn underwater, which we're not going to require you to do. You can do it voluntarily if you want to don your scuba gear and go sit in the pool, at the local YMCA. You're welcome to do that, but you don't have to. You get a 10% boost in the water condition. You get like a 20% boost in the studying on land and testing on land. So if you can boost the similarity within a subject matter, you can really enhance your memory in a meaningful way. All right. So I think so I got as far as context in here and forgot to advance my slide because I was talking and looking out the window. So the cues that are present while you're encoding information will be encoded along with the information. And a good example of that is context. Okay, so let's go ahead and take a little break here and we'll come back and we'll continue on with this encoding specificity hypothesis in the next segment.